Hello everyone, welcome back to the channel. Today we are diving into Leetcode 2438, the range product query of power. And if you ever struggle with the range query, modular arithmetic, or a power of 2, this problem will be your new best friend, and you will understand clearly because I'm going to start with very basic concepts. Okay, very first, let's understand through the examples, right, what we have given. It is saying that we have given a positive integers and we have given, means we will start with the number n. Okay, so let's suppose n we have given is 15, right? What we have given, and we have given 15, okay? So we'll break it into the minimum power of 2, that sum to n. Okay, so for example, let's suppose we have n we have given is 15, right? N we have given is 15, and if we make the conversion, as you can see the power, it is saying 1 to 4. It means 1, 2, 4 and 8. It's a power of what? It's a power of 2. So when we write power of 2 means, let's suppose 0, power of 1, power of 2, right, like we can say, and power of 3 means 2 to the power 0, 2 to the power 1, 2 to the power 2 to the power 3. If you say 2 to the power 0, it will give you 1, 2 to the power 1 is will give you 2, 2 to the power 2 it will give you 4, and so 2 to the power 3 will give 8, right? If you'll do the sum, right, just do the sum, you do plus plus plus, what you will get? So 8 and 2 is 10, and 1 and 4 is 5, total it is 15, and that we have given is 15, right? That's because 15 is a binary. Uh let's suppose n is equal to 15, and we have seen it becomes with the power of 2 with the 1, 2, 4 and 8, right? This is because 15 in binary is 1 1 1 1, right? So each one represents the power of what? It represents a, each one here is represents what? A power of 2. Means there is a power of 2, power of 2, power of 2, power of 2 at 0 for this one, power of 2 at this one, power of 2 at this one, power of 2 at this one, right? Means all the one bit is representing, right? And then we got this 15, right? Can we say that it is understandable, right? Now think about what we have given other things, right? So then we get a queries, right? Let's suppose we have given the queries like left and right, right? So for each query, we will multiply all the numbers in the range, right? Or one more thing, since the result can be huge, right? We have to take the 10 to the power 9 plus 7. Okay. What I'll suggest, you pause this video and go through the statement so you will understand. Okay. So this is the very first thing that you should understand. So what we have given, it is saying that we have given positive integers, that is there exists a zero based array that is called powers, right? That we have seen that this is a power. Now we'll compose the power of minimum number of power of 2, and that's sum up to n. So the array is sorted in non-decreasing order, and there is a one way to form the array that we have seen. It is also saying that you are also given zero indexed integer, that is queries. So queries at each element is left and right, right? This is a boundaries, right? So each query represent the query. You have to find the product of all powers at I, at j, and j should be left within the range. Okay, we have to return the array answer equal to the length of the query. The answer at I is the answer of ith query. Since it is maybe large, you have to take the modulo. Okay, I hope you understand. So if you see the answer to the first query, right? So the very first query we have given is 0 and 1. The very first answer to the query is power at 0, and we'll multiply the power of 1. So power at 0 is 1 and power at 2 is 2. So if you multiply 1 into 2, it will give you what? 2. Similarly, if you multiply 2 means 2 into 2, right? Means power at 2 is what? power at 2 we have seen, right? What we have seen 1 2 4 and 8. This is 0 1 2 and 3, right? So 2 and 2 is 4 into 4, we'll get 16, right? 0 1, right? So it is saying power at 2 we have given is 2 2, so we'll get 16. Can we say that? Then we have what? 8 we have given, 0 and 3, right? Power at 0 is 1, and this 8 is 1 8, right? Like this we have given. So if you will apply all this query, you will see that we will get this value. Okay, very first, what we need to understand, let me show again. Okay, so as you can see in this example, what we have given, n is equal to 15, powers we converted into, we have converted this power into 1 2 4 8. And if we, so it also saying the power cannot be a smaller size, right? Answer to the first query is 0 and 1. So will power at 0 will multiply power of 1 will multiply is 2. Then power, then answer to the query is power at 2, because there is 2 2. So we'll say not 4 into 4, we'll just say 4. Okay, now it is saying 0 and 3. So power to 3 is 0 into 3 is, will multiply these things, right? And then power at 0, power 1, power 2, power 3. If you multiply from 0 to 3, right, you will get this value. Are you understanding what is happening here? So when 0 and 1 means we have the range 0 and 1, between 0 and 1. Let me show you how. So when we write, let's suppose if we want to write the range, right, queries. So queries start from where? At 0. Let's suppose is 1. Then we have is 2. Then we have is 3. Okay, how many queries is there? These are the queries we have given. Okay, so each query having left and right, correct? So here when we talk about 0 to 1 means this is left, and this is right. So this is query 1. So when query 1 we are seeing that, then we have to multiply both at here, at left and right, both. Okay, we'll multiply 1 into 2. But when we reach, when we the query written here left and right both at one place, so we'll just make the power from 1 into 2. Because there is range is between only one place is there, left and right both at one place. So we'll just do add to what we have is 4. So it power we have is 1 2 4 8 0 1 2 and 3, right? This is, let's suppose, like an array, right? So we'll only multiply with this 4. Then answer the third query from is from 0 to 3, right? Means how many we have to take. This one we have to take, this one we have to take, this one we have to take, and this one we have to take. So all we have to take, power 0, power 1, power 2, power 3, all we have to multiply, and then we'll get 64. And that is why the answer is coming 2 4 and 64. You understand this one? So if the power of 2, if we'll find, what will come here for n equal to 2, it will be 2. So power 0 is coming 2, so just will return 2, as we have seen for this one, this case. This is a similar case. Okay, so like that you have to implement. I hope you understand the problem, right? So what we have given n, we have given, right? And we have to generate the power, right? A power array. And then we will get the query, like we will have the left and right, and for each query we will multiply all the numbers in that range, right? And one more thing, since we have to take the resultant in the modulo, so we have to take the modulo also. Okay, so what is the intuition? Since we are given number n, we have given, right? And we have given the queries we have given, right? What we have given, n we have given, and queries we have given. Okay, so the queries that ask, we have to multiply certain consecutive power of 2 up to n, right? Up to n, as you can see in this example, right, that we have given. Okay, so the key is the power array is fixed, right, for n, for the n, right? And it comes from the where, from the binary representation that we have seen, right? For 1 1 1, right? We have what for 15, right? So from the binary we will do, so from, it comes from the binary representation. So what we will do for each query, right? What we need to do for each query, we for each query, what we can say, it will just ask the product of the subquery of the power, right? And we will get it. So it is up to 10 to the power, how 10 to the power, it will call 5. If you go to the range, right? If you go to the constraint, you will see up to the power 10 to the power 5 queries we cannot multiply from the scratch each time, so that will become slow. O of m cross q, can we say that? So to do, it becomes so slow, right? So we should not multiply this from the scratch, from 0 and 0 to 1 and then 2, right? We have already done 0 and 1 multiply, we have already done, right? As you can see here, only we need to multiply these things, right? So we should pre-compute some commutative product like prefix, some we are doing, right? Similar to that, we will do the prefix product. Okay, we'll find the prefix product so we can answer each query in O of one time, right? And then we'll take the modulo to prevent the overflow. I hope you understand, right? So very first, in your mind, you will say that how to get the power array, right? So we get the power of 2. Let's suppose n, or you can say some value is there, right? Some value is there. So to get the power of 2 from n binary form, right, that we have seen, for each bit position starting from the least significant bit, right? LSU, least significant bit, right? The if the bit is the bit is set, right? If the bit is set, what we need to do, just do 2 to the power I, right? And then to the list power list, we can say that, right? If it gives you, right, the minimum power of 2, that will do the sum. Means let's suppose we are talking about the n equal to 15. So we saw that binary is what, 1 1 1 1 1, right? So when do the power, when we'll write the power, right, just we need to do what, we know all are 1 1 1, right? So we'll start from 1 2 4 and 8, like that. We'll start from here 1, okay, 1 2 2, this is 3, and this is this, like that we will do, right? We want to do, right? We'll start from the least significant bit, and if the bit is set, we will add 2 to the power I, right? So this is 2 to the power I, okay, add it to the power. Then we'll see, okay, another bit is set, just write to the power I. Another bit is set, write the 2 to the power I. Another bit is set, write the 2 to the power I. Like that we will keep adding that and we'll get the power. Okay, this is your power. I hope you understand. Now you will say, then how we will get the fast range product query? Okay, means the product sum. Just you need what, prefix at I you will do. You will multiply power at 0. You will multiply power at 1, and so on till power of I. Correct? You will do that, and just you, if you it is big number, you will take the mod. Okay. Let me clean in that. Will write it. Okay. What I'm trying to say, if you want to find the prefix, you want the prefix at I, there will be some list of product, right? The product, not product, the power, right? Power at I will be multiplied with all, right? So let's say very first is 0, then it will multiply the power of 1 1, and so many will be there, right, till I, power at I. And just you need what, mod. Understand? And to get the power from left to right, right, to get the power from left to right, if left is 0, the answer will be what, right? We have seen prefix at R. Else what we need to do, answer both we have to multiply. How? Prefix at R, and we do mod inverse. You remember mod inverse? We'll do the mod inverse and we'll write prefix and we'll write L minus 1. And then you can take the mod if you want the mod. Okay, means the mod inverse is nothing but what? Remember, mod minus 2, and we'll take the mod. Which theorem is this? This is a Fermat Little theorem, right? Based on that, we have to find the inverse mod, right? Why we are going to use the inverse mod? Let's understand. Very first, if you write the prefix at r, okay, so we have seen that we'll use the power at 0 and we'll keep doing that and we'll multiply power of r. Can we say that? So if I will write this prefix at L minus 1, we'll do the same. Power at 0, we'll keep multiplying that and we'll multiply what power at L minus r, not L minus, this L minus 1, right? So can I say power at L, we can multiply so many things, so many powers, then we'll multiply power at r. Can we say that? We can do that. Is it equal to power r divided by prefix L minus, or not r, L minus 1. No, this is also prefix. This should be prefix also, right? Because that is prefix. So power at L multiply with all the in the range from left to right. We'll multiply the power left to right, right? It is equal to prefix at r by prefix at L minus 1, right? So in modulo math, division is replaced by what? It is replaced by multiplication. You just take this in the multiplication and you will get the modular inverse. Okay, better let's understand the code so you can understand easily. Okay, it's not a tough question. So very first we need the mod, right? And we have given this queries, right? Let's understand how. So we have given n, we have given, and queries we have given, right? So very first what we need to do, we will extract the power of 2 from n, right? So for that we have the power and we can get the power like this, right? We can get the power. Okay, we have to pre-compute this power. Then we'll check the the prefix product, how to find like this. We will find the prefix sum, right? Not prefix sum, prefix product, and you can take the mod as I told you, right? Then we'll take the inverse mod, right? So you will find the inverse prefix here and we'll pre-compute or the modular inverse of the prefix. Then we'll apply the queries and we'll find the answer. So if you find the queries, you will get from the all the n, right? O of n, you will get the left and right. This is your boundary condition. You will do the validations. You will do the validation. Then you will find the left and right. So you will get the answer from the left side, answer from the right side, right? And I told you, you will not do the divide. You will just do the multiply in the inverse condition, right? Because we can do in the inverse condition, right? Because the modular is it not you can multiply it directly, so we can do that. And this is the mod power function that we have seen many times. Okay, so I hope we understand this problem. If you have any doubt, let me know in the comment section, guys. I'll see you in the next one, and let me know if you have any doubt in this video. Thank you for watching this video. I'll see you in the next one. Bye bye.